In the next couple of videos, we're going to talk about special triangles. We're not actually going to define special triangles yet, except to say that special triangles are right triangles that have exact primary trig ratio values that you will eventually memorize. So what we're going to look at in this video is a problem that's going to help you memorize these special triangles. This is a problem that was given to me by one of my colleagues. I've always quite liked this problem, and I always say to students, when you have a test or something that has special triangles in it, making a little quick sketch of this diagram is useful to help remembering the values. So let's go through this, shall we? So given RSTU is a rectangle, RSTU is a rectangle, RV is 1, so let's actually write here RV is a value of 1, VU is root 3, and angle WVU is 30, WVU is 30. We want to find all lengths and angles, and the values should be given in exact form. So what that means by value should be given in exact form is, see how here we have root 3? I should definitely not write that out as a decimal, because then it's no longer exact. So I think you should pause the video now and give this a try on your own. Just make a quick sketch on paper, and then you can unpause the video and I will work through it for you. Okay, so let's dive in, shall we? So we know that RSTU is a rectangle, so that means angle R should be 90 degrees, angle U should be 90 degrees, and angle T should be 90 degrees. So now, if we know that there's 180 degrees in a line, and angle WVU is 30, angle WVS is 90, that means angle SVR is going to be 60 degrees. And if I see triangle WVU has an angle of 30 degrees, 90 degrees, that means angle UWV is going to be 60 degrees. And now I need to get some lengths. Oh, not quite yet. Pardon me. Right there, angle RSV should be 30 degrees. There we go. So now I have to get some length if I want to go any further. Now this is where students have a bit of a challenge, but one thing we've talked to students about is, remember I've said that one thing you should have memorized is what is sine of 30 degrees. So I say this right from the very start of teaching trigonometry because it's a way to check if your calculator is actually in degree mode. If you know that sine of 30 is 1/2, that's a great one to know. So now let's just talk about what this means. So sine of 30, the ratio is 1/2. Remember, sine is opposite over hypotenuse, so this 1 represents the opposite, and this 2 represents the hypotenuse. So if I take a look here at this 30 degrees, if this 1 here is the opposite, what that means is that this has to be a value of 2. And if this is the value of 1 and this is the value of 2, we can then calculate length SR using Pythagoras' theorem. So therefore, we can say that 2 squared, so hypotenuse, is equal to 1 squared plus RS squared. And now I can do a little rearrangement, and I get RS squared is equal to 3. So therefore, RS is equal to the square root of 3. So that means this length from here to here is the square root of 3. And now what I say to myself is, well, notice 30, 60, 90, 30, 60, 90. If RS is root 3 and VU is root 3 and the same angles inside the triangle, that means that UW must be 1 and VW must be 2. Okay, so now what conclusion can I draw? Well, there's lots of places we can go from here. One thing I could recognize is, let's take a look at triangle SVW. Notice that I have two sides that are equal. If I have two sides that are equal and it's a 90-degree triangle, that means that the other two angles must be 45 degrees and 45 degrees. Well, I could actually figure out SW now using Pythagoras' theorem. So we're going to say SW squared is equal to 2 squared plus 2 squared. So SW squared is equal to 8. So SW is equal to root 8. And I know that some students are already comfortable doing this, so I'm going to actually write it out this way. I can rewrite 8 as 4 times 2. And so one of my mathematical laws is if I can rewrite the value 8 as the product of two numbers on the root sign, I can take the root of each of those separately. So the square root of 4 is 2, and then I can't take the square root of 2, so I leave it as that. So this length here is 2 root 2. I'm almost there. So we know that angle TSR is 90 degrees, and if I have 30 degrees and 45 degrees, that means what's left over is another 15 degrees. If I have 15 degrees and 90 degrees, that means that this angle here is going to be 75 degrees. I can do that with a little bit of math. And now I have two more lengths to figure out. I need to figure out ST and TW. Well, notice if I travel ST, it's the same as traveling from R to U. And I can travel RV, and then I can travel VU. So if this is 1 and this is root 3, the total length up here is 1 plus root 3. This is an important geometrical moment to make sure you understand. So if I travel 1 and then root 3, if I travel that whole distance, I've traveled 1 plus root 3. Now, if I want to look at WT, it's a similar type of argument. Notice, if I travel RS, it's root 3. But if I travel TU, it's root 3, but then I need to go back to W. So notice I travel from here to here and then back 1, so it's going to be root 3, which is the distance from there to there, minus 1. And let's put a red line here to make sure we separate this. And now I've filled in that entire diagram. So this is a really useful diagram that you can sketch out really quickly and through some common sense figure out. And it's always going to let you know the exact values of a couple of your core special triangles and one unique special triangle that people often don't encounter. And we'll talk about that in our next video. I hope this helped.